Good day, everyone. My name is Nurmaisara Afika binti Ariza, and today I will be presenting my research proposal titled Synergistic Anti-Tumor Effects of Oxadiazole Derivative with Chemotherapy on Human Breast Cancer Cell. This presentation will outline the scientific rationale, methodology, and expected contribution of this study. Here is the outline of my presentation. I will begin with an introduction to breast cancer and the limitation of current chemotherapeutic agents. Next, I will summarize key literature supporting the anti-cancer potential of oxadiazole derivatives. After that, I will highlight research gaps, followed by the research questions and also the objective of this research. I will then describe the methodology, including cell lines, MTT assay procedures, and combination index analysis. This will be followed by the expected findings, potential scientific implication, as well as the project timeline and also the budget that will be needed to complete this project. In this introduction slide, I will be sharing about breast cancer overview. Breast cancer remains the most common cancer among women worldwide and contributes significantly to cancer-related mortality. Despite advances in early detection and treatment, the long-term effectiveness of chemotherapy continues to be hindered by drug resistance, dose-limiting toxicity, and tumor recurrence. Common first-line agents such as doxorubicin and 5-fluorouracil play a central role in therapy, but are associated with cardiotoxicity, gastrointestinal toxicity, and reduced efficacy over time. This highlights the need for improved therapeutic strategies that can enhance treatment response while reducing harm to normal tissues. Next, we will be talking about the rationale for oxadiazole derivatives. Oxadiazole derivatives have gained increasing interest due to their strong anti-cancer activities, favorable drug-like properties, and the ability to modulate key cancer signaling pathways. They also offer structural versatility for optimization. However, despite promising cytotoxic effects, their synergistic potential with standard chemotherapy drugs, and in this study, which we will explore, doxorubicin and 5-fluorouracil, they remain largely unexplored. This forms the motivation for the current study. In the next section, we will be talking about the literature review, where I will share four papers that would explain further why this research is needed. The first literature review would be by Devaraji et al. 2025. Devaraji and colleagues synthesized 15 indole oxadiazole derivatives and evaluated them against MCF7 and MDA-MB231 breast cancer cell lines. In their studies, the most active compound demonstrated an IC50 value of approximately 13 micromolar. This outperforms the 5-fluorouracil. And then after that, they would also do a docking studies which further supported strong affinity towards cancer-related targets such as mTOR and EGFR. From this study, we can see that it highlights the therapeutic potential of oxadiazole-based molecules. The second paper, which is a paper by Salem et al. 2025. In this paper, a comprehensive review by Salem and colleagues summarized 2 decades of research on oxadiazole derivatives. They reported potent cytotoxicity across various cancer cell lines, including MCF7 and MDA-MB231. In this study, the key mechanism included topoisomerase 2 inhibition, EGFR, and HDAC8 suppression, apoptosis induction, ROS generation, and cell cycle arrest. The results from these studies would be some oxadiazole analogs achieve remarkably low IC50 values, even outperforming doxorubicin and also 5-fluorouracil. This positions exodiazole as a highly promising anti-cancer scaffolds. In this slide specifically, we will be talking about the synergistic and mechanistic studies, which can be shown by these two papers. First, Banerjee et al. Demonstrated broad anti-cancer activities among structurally diverse hexadiazole derivatives, which this reinforced the scaffold's pharmacological strength of oxadiazole derivatives. Similarly, Bomera et al. Also developed oxadiazole-linked 5-fluorouracil hybrids, which has superior cytotoxicity and stronger binding to thymidylate synthase. Together, these studies support the potential of oxadiazole structures to enhance chemotherapeutic efficacy. So, why this research? From all the research paper that I have shared, despite extensive evidence of anti-cancer activities, the synergistic potential of oxadiazole derivatives with standard chemotherapy remains underexplored. There is limited work evaluating combination index values, optimal drug ratios, and selective toxicity towards normal epithelial cells, which this gap provides the foundation for the current research. Since I have shared the research gap and the literature review that strengthen the reason why this research needs to be done, I will now move on to the research question, hypothesis, and also the objective of this research. First of all, a research question. The number one research question would be, do oxadiazole derivatives alone exhibit anti-tumor effects against human breast cancer cell? Or the second one would be the oxadiazole derivative in combination with doxorubicin or 5-fluorouracil exhibit antitumor effects against human breast cancer cells as well. So this is what we need to explore. Hence, why the hypothesis would be the first one would be the null hypothesis, which is the hexadiazole derivative do not exhibit antitumor effects against human breast cancer cell. And the alternative hypothesis would be the oxadiazole derivative do exhibit antitumor effects against the human breast cancer cells, which brings us to the objective of this research. The first objective would be to evaluate the antitumor effects of oxadiazole derivatives alone on human breast cancer cell. And the second objective would be to evaluate the antitumor effects of oxadiazole derivative in combination of doxorubicin or 5-fluorouracil on human breast cancer cell. The methodology of this research would be divided into three parts, three main parts, which are cell lines and cell culture. The next part would be cell viability assay, MTT. And the last part of the project would be combination index analysis. This research will utilize three breast cell lines. The first one, namely, is MCF7, which represents hormone receptor positive breast cancer, while MDA-MB231 represents the aggressive triple negative subtype. And the last one would be MCF10A, which serves as a non-tumorigenic epithelial cell control, which is used to assess selective toxicity. All cell lines in this study will be cultured according to the ATCC guidelines. MCF7 and MDA-MB231 will be grown in DMEM supplemented with 10% fetal bovine serum and 1% penicillin stratomycin, whereas MCF10A requires a specialized medium consisting of DMEM/F12 supplemented with horse serums, EGF, hydrocortisone, cholera toxin, and also insulin. All cultures will be then incubated at 37 Celsius with 5% carbon dioxide in a humidified environment. Cells will also be maintained at 70 to 80% confluence to ensure optimal viability and consistency before treatment. Why, you may ask, this needs to be done is because these standardized conditions ensure reproducibility and reliability of experimental outcomes. The second part of the methodology involves MTT cell viability assay. This part of the research is needed to evaluate the cytotoxicity of oxadiazole towards the breast cell lines that was measured in earlier slides. First, 15 oxadiazole derivative, which was retrieved from Prof. Puniakoti lab, will be prepared as 100 micromolar stock solution in DMSO and diluted to working concentration of up to 50 micromolar. The next step would be the cells will be seeded into 96 well plates and treated for 72 hours. And after 72 hours, MTT reagent will be then added, followed by the solubilization of formazine crystal. And then observance will be measured at 570 nanometer. The last part of this section would be the IC50 values will then be calculated from the dose response curve. Let's now move on to the last part of the methodology, which is combination index CI analysis. To carry out this part of the study, the hexadiazole derivatives will be combined with doxorubicin or 5-fluorouracil. Then, a fixed ratio concentration based on each drug's IC50 value will be used, and the combination will be applied to MCF7, MDA-MB231, and MCF10A cells. After all of these are done, the final DMSO concentration will be kept below 0.05% and the cells will be incubated for 72 hours. Lastly, the cell viability will be measured using the MTT assay again, and the observance data will be processed using CalcuSign to generate combination index values. So in this slides, I will be explaining about the software and the parameters that should be used in CalcuSign. So drug interaction analysis will be performed using CalcuSign B2.1, which applies the Chow-Talalay equation. This software generates two key parameters: the combination index, where CI is less than 1, which indicates synergy, and the dose reduction index, which shows how much each drug's dose can be reduced for the same effect. Together, these values provide a clear assessment of whether hexadiazole derivative enhance the effects of doxorubicin or 5-fluorouracil. Moving on to the next section, we will now discuss the potential implication of this research. So the expected findings that we can deduce from this research would be several hexadiazole derivatives are expected to demonstrate meaningful cytotoxicity, particularly against MCF7 and MDA-MB231 cells. Based on previous evidence, certain compounds may also produce synergistic interaction when combined with doxorubicin or 5-fluorouracil, potentially enhancing overall anti-cancer activity. A degree of selectivity is also anticipated in this research, where cancer cells respond more strongly compared to the non-tumorigenic MCF10A cells. Such outcomes would indicate the possibility of achieving effective therapeutic responses at lower drug concentrations, which could help reduce treatment-related toxicity. Overall, these findings would support the potential of oxadiazole derivative as a promising chemosensitizing agent in breast cancer therapy. What about the scientific implication involved in this research? From all these positive results, it could provide strong evidence for using oxadiazole derivative to improve chemotherapy effectiveness. This may contribute to strategies aimed at overcoming chemo-resistance and also reducing toxicity in breast cancer treatment. By reducing toxicity and overcoming chemo resistance, it could help the overall experience of the patients when going through chemotherapy. So now that I have explained the potential implication, we will now move on to the budget, timeline, and also the milestone, as every single research would have their own budget, timeline, and milestone to achieve. So the budget needed for this research would be a total of 10,000 ringgit Malaysia. It consists of mainly a 50% of consumables, 45% of the kits, and 5% of the research lab maintenance. The consumables include cell culture media, fetal bovine serum, PBS, DMSO, and the disposable lab items. Next would be the kit that covers cell titer glow viability kit and DNA accession kit for experimental assays. Because we are using IMU lab, then the research lab maintenance would be 1,000 ringgit Malaysia. This is because for shared facility usage, utilities, and also general laboratory upkeep. The Gantt chart shows the overall timeline of the research. The project timeline follows the structure outlined in the official research proposal. Cell culture activities will begin in the month of March and continues up until the month of June. This phase includes stowing, expanding, stabilizing the breast cancer cell lines, and ensuring they reach consistent growth before viability testing. Next, the cell viability experiments would run from the month of March until the month of July. This period allows sufficient time for dose response optimization, triplicate repeats, and verification of IC50 values for all oxodiazole derivatives. And lastly, the combination index analysis would start in the month of April, which then will continue until the month of August. Lastly, the combination index analysis would start in the month of April and continues until the month of August. This overlapping design ensures that CI experiments can begin as soon as reliable IC50 values are obtained, which allows the project to progress efficiently without any delays. These three phases, cell culture, cell viability, and CI analysis, would span from the month of March to August, with clear milestone targets at the completion of each month, which ensures steady and systematic project progression. As you can see here, this would be the list of reference used in the slides. That's all for me. Thank you so much for listening. And if you do have any questions regarding this research or even in regards to my presentation, you may connect with me to the email stated in the slides. Thank you. Have a good day, everyone.